So welcome to my little talk, Microservices, the end of software design. And yeah, I'm Ole, currently available. And yeah, who am I? Got 25 years, roundabout of professional software development background, and almost 20 years with Java. So I will talk a little bit about that. And 5 years of Go now, and I'm currently co-organizer of the Berlin Go meetup for about 3 years now, and often worked as software architect or similar technical team lead or whatever it was called. Now you would call it probably a lead engineer or maybe principal engineer, something like that I would like to find now. And yeah, let's talk about the old things, the old days, because we need this background to understand the whole thing. So in the old days, there were only the monolith. This was the only architectural pattern that was really ever used. And you didn't even have this word really at the start because it was just a system, and that one system would be one deployable unit was never questioned by anyone. And operations insisted on it because they had to deploy everything with a quite long manual process. And if you would ask them to do this like 5 times, they would have refused to operate your thing at all. And yeah, even developers didn't question it really, because for us developers, it was easy to add something new and you didn't have to do all the scaffolding again and so on. So yeah, it wasn't really beautiful when the thing became more and more fat and so on, but it was okay. It was simple. Every step, every change that you did, it was still more or less the most simple thing that you could do. And so it has never been really questioned. And yeah, systems grew without bounds, right? We know that's why these monoliths became huge, and usually they became a big ball of mud and yeah, lots of spaghetti code, and it was unable to be maintained after a while. And even some companies went more or less down because they couldn't develop their system further anymore in a timely manner. And so other companies, competition could catch up easily, and then they had a hard time to stay in business at all. And yeah, that's the old days. Let's take a look at it. So typical class diagrams looked something like this. So you have at the outer edges and sometimes things that were quite okay, right? And here you even see something that has some thing regularity, and you think, yeah, this might make sense. But then in the middle, yeah, this is quite a mess, and you can't do anything with it really. And yeah, this is the big part where nobody wants to touch it really, and you are not really changing the code you want and forming the system the way you want, because the system is dictating you that you shouldn't change it or do much about it anymore. Yeah, and another example, this is even worse. Here you have colors to see anything at all without these, I think they are about concerns. Without the colors, you wouldn't see anything. It would be just a mess of lines and dots. And still few things at the outside that you can understand, but overall good luck with maintaining such a thing, right? Yeah, and software design is really the art that tries to keep this mess at bay, right? So from Wikipedia, they say software design is all the activity involved in conceptualizing, framing, implementing, commissioning, and ultimately modifying complex systems. I think this is a bit too broad because this would include software architecture too, and implementation, and maybe even testing and so on. This is just a bit too much, I think. So the definition that I understand and always worked with is software design is the thing where you try to optimize everything within one system. Right, so it's not so much about the outer bounds and interfaces to other systems or to databases and so on. That was more software architecture, and software design is focusing on the inner structure of the system. So that's the definition that I will work with. And yeah, so let's take a look. It has been a real reputable discipline, right? There were a lot of books about it. I have been reading that one and liked it quite a lot back in the days. And yeah, so the old system, many or most of them have been done in Java. So we have to talk a bit about that. And unfortunately, it's relatively bad for software design, especially when things get a bit bigger. That's why I have this little broken cup here. And I wouldn't be allowed to use the original Java logo if I wouldn't use Java in a purely positive way. And sorry, I have to criticize now. So I'm not able to do that. I prefer to use something else then. So Java allows circular dependencies more or less on any level. So between classes, this is normal. There are patterns where you need this and so on. So, but it allows as well circular dependencies between packages. And this is the crucial part. And finally, it doesn't really encourage nor truly prevent circular dependencies between projects. I've never seen a problem with that back in the days, and I think nowadays it should be even less of a problem since the tooling has been advanced a bit on the Java end too. So the crux is really these circular dependencies between packages. And yeah, and of course between classes that are in different packages too. So, and this can be when you have a big system, a big monolith, and you can just use anything, anywhere that's not private or so, and then you can have circles easily. It's really hard to digest and really hard to understand and refactor later. So let's see what tools we have for software design. And that looks quite good, actually. So IDEs contain traditionally quite a lot of tools. And structural analysis, for example. And yeah, we all know renaming classes, methods, variables, moving classes and methods possibly to different packages, extracting methods, splitting up classes. So there's quite a lot going on in classical IDEs, and this is the thing that helps to keep Java projects alive at all. right? The big old projects, they would be impossible to work on without these tools. And yeah, big companies build their own specialized tools, especially Google is famous for it. I've never worked for them and never experienced it firsthand, but they seem to have a really wonderful tool set that nobody else has, more or less, and must be great, but I don't know much about it. But it's probably that they add a lot of things on the higher levels, and you can do a lot of powerful things with that. So this is quite great.
I'm not even sure, because I mean, just I don't want to interrupt, but I worked at Facebook. Huge code base, messy code base, no tools.
Okay, and even no tools. Sorry for that. Yeah.
So I'm not even sure Google has tools for software design, honestly. Anyway, sorry to interrupt.
Yeah, no, thanks. It's a nice addition, right? I didn't know that. That's good. Thanks. So now let's take a look at the newer ways. Now we have microservices, right? And this is now more like one system and 1,000 deployable units. For smaller companies, less, of course, but there are larger ones that have something around that number. And yeah, now you have DevOps and cloud native and so on that almost insist on it, right? This is just the fancy thing of the day a bit. And yeah, is it questioned? I haven't seen it questioned much. I would like to do this a little bit today. And I don't want to go back to the old monolith, of course, right? Because this was just too much. But this can be a bit much too. But let's see. Systems still grow without bounds because, you know, if it's possible and there's a need somewhere and so on, the customer's paying, you will want to add this feature somehow. And so this is the one constant thing that it will always be the same probably. And yeah, usually you get now a spaghetti architecture, right? It's not spaghetti code anymore within one deployable unit, but now you have spaghetti between the deployable units. And yeah, what does this look like in real life? So you might recognize this diagram from before. That is because this is really the service diagram from Uber. And you can't find any class diagrams anywhere anymore. I mean, they are hidden in the companies and they don't show them anywhere. You won't find them on the internet. And maybe some very small ones for teaching, but something big of a monolith you never find. And they weren't readable at all anyway. Even worse, a little than this. Usually didn't have colors, so it was only black lines and dots. And you had different types of arrows, and that didn't make it much better. Only in the small. So this is from Uber introducing domain-oriented microservice architecture, and it still holds, right? There are some nice systems at the outsides, but the inner workings here in the middle, this will be really hard to maintain moving forward for many years. The other one is from Monzo, right? From their famous blog post, how they keep 1,600 microservices spinning. I didn't count the dots here, but this is a lot, right? And they say Go helps. Yeah, I hope. Clean code, sure. and a strong team. And yeah, probably a very strong team you need. And if you have some old members of the team leave, then it will be very hard to maintain this and understand this. Maybe they get big enough and have money enough to get better tooling and so on, so they can refactor this in a good way, and it's not as static as it is for most other people. Let's see, what are the downsides really? So the downsides of this spaghetti architecture is really updating a dependency for all these microservices, like just a simple logging library or something, can be really hard, especially when different services use a slightly different set of the API of that library. And then you can often migrate like 80% of the services very quickly, but then the other 20% can be really, really hard. And 20% of 1,000, it's still quite a lot. And yeah, you don't want to do this in a manual way. And yeah, I don't know how they handle this, and yeah, would like to know one day maybe. But this is no fun, and smaller companies will have a really hard time with this alone, even though this is the simplest part. Moving functionality to other services. Yeah, this is very tedious. The best thing I've seen is really just copying files or code from editor windows from one to the other. And yeah, I haven't found any tools for this, and might be a good business idea now to start developing such tools. Otherwise, I don't know how people will want to do this in the future and want to survive. Yeah. And this makes cutting services in a different way, of course, almost impossible. Right? You need many, many changes to move the whole way you were cutting services to something slightly different. Even if you're only like 10% far away from the perfect solution, then these 10% can be still very, very costly to achieve. And yeah, this is hard. Many companies just declare that they have found the perfect model and didn't do any of the mistakes that all the others do, and that's it. I'm not believing it usually, and all the things that I've truly seen weren't that perfect. And so, yeah, I'm a bit careful there. Sorry. And so let's take a look at Go and what we can do with software design here. And Go itself is really great, right? It has been engineered with scalability in mind. And packages are made for encapsulating functionality, of course. This is the purpose. And dependency cycles between packages aren't possible. The compiler simply doesn't allow it. And this can be a bit annoying sometimes, but in general, this is a huge benefit compared to Java. The whole class of problems is going away, and we don't have it all in the Go world, that the Java world has to fight a lot. And yeah, so this is, I think, one of the best design decisions that they did for the Go programming language. And yeah, tooling for preventing other unwanted dependencies is rather simple. right? Because you don't have to take care of the cycles anymore. It's quite simple to do, and it's easy to pass Go code and so on. So I would like to show you now a little tool that can do this. So it's Spaghetti Cutter to win the fight against spaghetti code. Right? And it's open source, it's documented and ready to use. That's the URL of the project. And it's really just a simple command line tool. You can use this in CI or CD pipelines, and of course in the development machines, right? And it prevents Go spaghetti code with error messages and the return code. So if the return code isn't 0, then there has been something wrong, and you get a nice error message with it. And the CI/CD pipeline usually catches this and sends you the error messages via email, and the build fails, and that rings the alarm, and everything should be easy to fix, and it should be fine. So it doesn't really magically cut anything, right? But Spaghetti Preventer is not a good project name, so I called it Spaghetti Cutter. Right? And finally, the configuration for this tool gives you a really nice overview. It's usually just a few lines, and you get a pretty great overview what the project in general looks like. And this is something that I've been missing quite a lot of times, and so I'm very happy about that now. And you can just call it with optionally root, right? Default would be the current directory. Otherwise, you can give it the root of the project, so where your source code is. And yeah, as I said already, the configuration is very important. And especially path configuration is important. So it's all about these import paths, of course, that you use, the imports in your Go code. And so what can you do there? Of course, you can do a very simple path, and you can do nested paths, as we do everywhere, but you can use a star too, and multiple stars even. And you could even use a star within a word, so it needn't be only next to slashes or so. So this helps you quite a lot. You can express quite powerful things with that. And a star matches anything except a slash. Right? This is the one exception. And so one example is that you could say, if you want to match a domain package, including its additional test package, you could just add a star at the end, and then this matches the test package too. And then finally, there's the double star. This matches anything, including the slash. And currently, it's only allowed at the end. I would be open to change this, and yeah, if there is interest and somebody has a use case for this, to use this somewhere in the middle or so, I wouldn't mind to change it, that it's just the same as a star, except that it matches a slash too. But so far I don't need it, and I haven't seen any proper use case for it, and it's easier to allow more later because it would be backward compatible than to make it more strict later. So I decided this way now. Yeah, and so what does the general configuration look like? The tools are supported, so you can have tool packages. So often you have an X package that has sub-packages that are the real tools. So this would be supported this way. You can have multiple entries here, of course. So for database, you can have every package under the DB package, be something for database access, and some people put their entities in the root, in the project root. So this would be the slash here, and you can do it that way. So what does it mean, tool package or database package? The tool package is a package that can be used anywhere within the project, except in other tool packages. And but it's not allowed to use any of the other packages itself. So it's kind of a leaf package, but can be used anywhere else. Database packages are allowed to use tool packages, but nothing else, right? And they are allowed to be used anywhere else in the system. So in the normal domain packages, but not in tool packages, of course. And in other database packages, it would be possible to use the database package too. And finally, I hope this is rarely needed, it's possible to declare God packages. These are the packages that can use and see anything, right? And by default, this main packages are God packages, and I think this is the same default. This is the idiomatic go way that main is the package that covers everything together. And so it has to see everything, and that's fine, but nobody else. And this is the default. And if you need something else, you can explicitly say so. And you can even say that there shouldn't be any God package, especially that this default shouldn't be true at all. And then you could declare no God to true. I don't know if how useful this is, but since it's nice if you do so and can do so for your code, I wanted to support this. And there's one final thing for the general configuration. Sometimes you have clever people who think, yeah, this is all a bit tedious. I don't like to think too much about packages, and it's just too annoying. I can do this one day later, maybe next month or so, when we have done this, finished this code and the deadline and so on, and then we will clean up. And now I do everything into one package, one single package, and all the code in there. I can have many files in there, and yeah, and so here you can declare a maximum size that is allowed. Right? This is not exactly lines of code or something. It really is measuring the code complexity. So formatting or anything like that doesn't matter. And if you split something up into multiple files or all in one file or so, this all doesn't matter. It's just measuring the code complexity. And yeah, the value is kind of the minimal lines of code. If you would make the lines as small as possible, more or less, you would come up with such a number roundabout. And yeah, let's take a look what else you can do. So this is the general thing. I think this supports like a lot of the web APIs that are currently built and so on quite nicely. And so anything that's not any of these three special packages is a normal domain package. And so it's allowed to use tool packages and database packages, but they aren't allowed to use each other. And only God packages can use them. Right, so main usually. And let's see, sometimes this is not enough and you want to allow something on top. So I have this configuration, allow additionally, and this should read allow superdomain to additionally import subdomain 1 and subdomain 2, right? Or this super tool to import additionally tool 1, even database packages or all database packages, and domain X. So, right, this would would be contrary to the rules that I just explained. And yeah, it's possible. It's not really that I would like such a configuration, but it's possible, and you explicitly say so. And you should add a comment why you did this and why this is necessary. And then I think it's much better than not making this explicit or trying to hide it or whatever else. And I think this never really happens, such an extreme case, but you can overrule any of the other rules. And this configuration is not pure simple JSON, it's HJSON, so human readable JSON. And so comments are allowed especially, and please make use of that. Right, then it's really good documentation, and the next can easily understand what's going on and why it's being done like this. There's one final thing that you can do. You can restrict something. So you can use this allow only in key, and this you can read as allow the subdomain 1 package to be only used within domain X and superdomain. So this, right, you see, these are the basic general rules. Allow additionally can overrule that, and this allow only in can even overrule the allow additionally. This is the one that overrules everything. And this is the only one that makes sense and can be used for external packages too. So you can say for external packages that, for example, the Postgres driver should only be allowed in main packages, which is idiomatic, right? That you do an underscore import there. And then you use, for example, SQLX for your OR mapping needs, and this can be used in all the database packages. And yeah, that's all you would need, and you can restrict things for the otherwise external packages are usually allowed to be used anywhere. There are no restrictions. Yeah, this is the standard, and you can restrict things this way. Let's take a look at the output. If you run the tool, this is now when it runs over itself, its own code base. So I've restricted here the HJSON package, as I told you already, that it's only to be used within the own config package. Makes sense, of course, right? Use it only for configuration. And then there is the xtools package, And this contains the Go parser and helpers for that. So this is allowed to be used in the packages that calculate the dependencies, calculate the size, and pass and X packages helper package. And yeah, I don't need any allow additionally things. For God package, I only have main. This is the default. And tool packages, I have everything under X, which is just idiomatic. And this pass package is somewhere between a tool package and a domain package. So I have this as a tool now. Might switch it over to a domain package. I don't need any database packages since it's just a tool running over the file system. Size, I only need 1024, and we see in a second why. So I don't use this no-God thing, and here it tells the root package that it's using. And this is quite helpful already because sometimes you might find a different root package than you thought it would use. And then this can be really helpful already that you get the output for the right project there. And then it reports all the sizes of all the packages. So you can simply use one value for size first, run the tool and look at what it reports, and then adapt the size to a reasonable value. And yeah, you see this size package itself is the biggest here. And this has to be able to pass all possibilities within Go code, since whatever you add, whether it's a for loop, an if loop, or whatever else, adds complexity. So I have to count it, and so I have to be able to pass it. And it's not possible to split it up into sub-packages, unfortunately. Yeah, no errors were found, return code is 0, and everything's fine there. So let's take a look what this gives us all. So software design is really dead a bit in microservice land now. I've seen microservices that contained only like 50 to maybe 100 lines of real business code, and then a lot of scaffolding around to decipher messages and send them, save something to database, and read from a queue, and so on and so on, and convert between different kind of data structures from JSON to something sent out over the internet to something for the database, and so on. There was a lot of scaffolding code, but not much business code. And then you can't do much software design in that, right? Because there's not much in there to design in the end. And you can't change a lot with that. Right? The problems that really make a difference are outside of it. So currently, I think software design is more or less dead, right? And yeah, but you pay a very high price for it. So refactoring such a spaghetti architecture is at least as difficult as it is to refactor a classical big ball of mud. Even though you tend to have more dependencies between classes, and you have nowadays between services, but if you use the typical queue pattern, it's often very easy to listen to another topic, to get another kind of data structure, and so you get another tither. This can be really difficult. So yeah, let's see. And I would really love to have something in between, compromise that is reasonably sized, maybe even naturally formed, right, according to concerns, according to how the business really works and what truly makes sense from the business side, not a purely technical way to split things up. And yeah, I think tools like this spaghetti cutter can help a lot preventing spaghetti code if you choose to have services that are a bit bigger again. And yeah, please enjoy your pasta and nice bites, right? And thanks a lot. And please, if you have any questions, please ask.